Okay, in this video we're going to talk about the configuration of EIGRP in a simple inter-network system. The first thing here we have three routers, RT1, RT2, and the RTR which is connecting between them. So we're going to use EIGRP routing protocol to route traffic between these two routers, RT1 and RT2. So configuring EIGRP is very simple. First, let's go to RT1. And we notice here the IP addresses were already assigned to the interfaces. So just for the sake of clarity, we can check show IP interface brief, just to see that IP addresses have already been assigned to serial interface and loopback 0 interface. Now, after having done that, I go to the global configuration mode, and then from here I initiate the router EIGRP, and I have to specify autonomous system number. Let's put 100. For your knowledge, autonomous system number should be the same for all routers participating in the same network system. For example, here RT1, RT2, and RTR, they all belong to the same network actually, or to the same administration, or under the same administration, so they should be assigned the same autonomous system number. So after we have done this, so let's see what are the different options in the router EIGRP. So what we can do, the first thing here is to specify the networks which are involved. In our case, we start with a loopback interface. Let's put 172.16.0.1, and then we can simply fix it with 0.0.0.0, which means that we inject this IP address. Do we need something else? No. Also, I can put the network address of the segment where the serial interface is connected. In our case, it's 10.0.0.0. Well, here I can put the class foot boundary network address 10.0.0.0. Okay. For the wildcard mask, I can simply put 0.0.0.0.3. Yes, because the subnet mask here is 255.255.255.252. Wildcard mask is actually the opposite or the inverse of the subnet mask, so we end up with 3, which means 2 bits only can be combined in this situation. And here we are. So we started with the first case here where we took the IP address of the loopback 0 interface and we simply fixed it by using this wildcard mask 0.0.0.0, which means that all the bits in this IP address are fixed, and here we just write the network address, class foot boundary network address 10.0.0.0, because 10 is the class A normally. And however, if you look at the IP address, you notice that we have here /30. So the subnet mask here, or the wildcard mask, should be the inverse of subnet mask, simply 0.0.0.3. Just think of the subnet mask as 255.255.255.252, and the inverse of it will be this. All right, so this is one way of doing. Now I can go now, I will go to RT2, and from RT2 I will configure also that router, the EIGRP, conf T. Now router EIGRP, I should use the same autonomous system number, 100. This is a must for the routers to communicate. If you give different autonomous system number, then routers will be in different autonomous systems, and then they will not communicate directly. At least they will not exchange routing protocol information directly. After that, I type the command network, and here I start with loopback 0 interface 172.31.0.0. So I will put the class foot boundary. It's a class B actually. Okay, if I consider this as class B, 172.31.0.0, so the wildcard mask will be the inverse of the default subnet mask for class B, which is 0.0.255.255. And for the serial interface, it will be, I can simply put it like 10.0.0.5, like I have done previously with the loopback 0 interface of RT1. And this time I will say that all the bits here are fixed, so the wildcard mask will simply be 0.0.0.0. So now we are done with this. Now let's go to RTR. In RTR, the situation is the same. So first, I will configure router EIGRP 100. You see, they all have the same autonomous system number, and from here, I will start dealing with the loopback 0 interface. So it will be 172.20.0.1. Okay, let me just fix it by putting wildcard mask 0.0.0.0. For the serial 0/1/0 interface, it will be network, I put 10.0.0.0, okay? No problem. So I just leave it like this to the classical boundary of class A. I don't need to specify any wildcard mask. Okay, or let me just do it for consistency. I can simply do something like this. 0.0.0.0.3, yes. You see now there is a neighbor relationship established between RTR and RT1, and for the other one it will be, I will put this 10.0.0.4. You see the subnet address here is 4, 10.0.0.4, and I can simply, for example, in some iOS they can accept subnet mask directly, like in this case. Let's try and see if the Cisco packet tracer does accept that. So I can put the subnet mask instead of wildcard mask, but the iOS of the router will convert this into the proper wildcard mask, which is like the 0.0.0.3. So let's see. Okay, yeah, it works. So now there is a neighbor relationship established between RTR and RT2. Now, if we go now to the configuration of the router, under EIGRP, router EIGRP 100, you notice here that the subnet mask we entered previously, which was here, the subnet mask, has been translated by the iOS into 0.0.0.3. So you have different ways of representing this information. Now, after we have done that, normally we go to the routing table and display what's going on here. So in order to isolate the routes generated through EIGRP advertisement, so we can simply write something like this, EIGRP, and here we are. So we notice that we have two routes. One route generated that goes to the loopback 0 interface of RT1, 172.16, but since it is subnetted because the classical boundary, normally the default subnet mask here is /16 or 255.255.0.0. Here it is /24, so there is subnetting. Since there is subnetting, it tells you here there is one subnet, and here it is. Same story with the loopback 0 interface of RT2, 172.31, normally it's a class B, 172.31.0.0/16, but since it goes to /24, it means subnetting is there. There is one subnet, which is subnet 172.31.0.0. Of course, when you borrow these 8 bits, you have 256 possible different subnets, but in our case, we're using only subnet 0, where all combinations of bits lead to 0 value here, so it works fine. Now, let's go to RT1, show IP route. Again, so let's just display the EIGRP route, and this is what we have. So we have this route here. We have another route, okay, all right, and we have a third route that takes you, this one takes you to the loopback 0 interface of RTR, and this one to the loopback 0 interface of RT2, okay. All right, you see, and you notice something here is that subnet mask is always used. For example, here this is the default subnet mask /8. In this case, it's the subnet mask /24, and here it's /24. So let me just go to RT2, and from RT2, I will display show IP route, EIGRP, and it is the same story here. So there is one thing actually is that if you want to see the subnets propagated, you have to visit every router. For example, like in this case, router EIGRP 100, and then write no auto summary. So just to disable the auto summary, where the router will try to summarize to the class with boundary of that class of IP address. Here also, router EIGRP 100, no auto summary. And again here RTR, okay, router EIGRP 100, no auto summary. Okay, after that, So we have the choice either to, for example, we can clear the routing table like this, clear IP route. All right. So I'm trying to clear the routing table. I can repeat this with the clear IP route. And I do similar thing just for the sake of being sure that everything was fine. Clear also IP route, just to refresh my IP routing table. And I go to RT1. Let's see what we have here. Show IP route, EIGRP. You see now, yeah, it's the same actually as before, but simply that we disable the auto summary. So from RT1 normally I should be able to reach the loopback 0 interface of RT2. Ping 172.168.1.1. It works fine. Let's trace route. Let's trace the route to 172.168.1.1. Yeah, we have two routers. So serial 010 of RTR is an inbound interface. So it's the first interface seen by RT1 message going to loopback 0 interface of RT2, and then the serial 0/2/0 interface of RT2 is the next interface and of the target. And since loopback 0 interface belongs to RT2, where the serial 0 is 0/2/0 is also there, so there's no need to show the last, because 10.0.0.5 represents the router where the loopback 0 IP interface belongs, or where this IP address is configured, yes. Now, what we can do, we can also start displaying, show IP EIGRP. What are possibilities? What are the interfaces where this EIGRP is enabled? So we have the loopback 0 interface and the serial 0/1/0 interface. Okay. All right, here it shows that there is no peer because it's a loopback interface, like it's a dead end, but for serial 0/1/0, there is one peer, which is the other end of the serial link that belongs to the RTR router. Okay, we can also display other information here, like neighbors. How many neighbors do we have? There is only one neighbor, which is the RTR router, and this neighbor is addressed through IP address of the serial interface to which RT1 is connected. 10.0.0.2, this is what you see exactly. The interface is serial 010. And the whole time, because you see the hello message are exchanged every 5 seconds, so normally every 5 seconds, so there is, yeah, the whole time here is 3 times the refresh time, or the hero interval, so 3 times 5, 15 seconds. That's why it will never reach 15 here. However, if a router like this router RTR does not receive hello message from RT1 for this period, for this duration, hold the time, then it will assume that RT1, or if RT1 here does not receive hello message from RTR for this amount of time, it will assume that RTR is not available anymore, so it will remove it from the neighbor table. All right? And 0 here simply means which neighbor was learned first, yes. Now we can go to RTR, and from RTR I can display the show IP EIGRP neighbor. And here we have 2 neighbors. So these 2 neighbors are identified through the IP address of the serial interface, their serial interfaces. Here it shows the serial interface to where RTR router is connected, at the other end, of course. And this is a hold up time, so 10 seconds, 14 seconds. So RTR will receive hello messages from both RT1 and RT2. If hello messages are not seen for this amount of time, it means that this neighbor is not available anymore, or the other one also the same. And when you see this values here 0 and 1, it means that this neighbor was learned first. Yeah, this is true because we configured the relationship between RTR and RT1 first. And then 1 here, it means that this neighbor was considered, was learned second. I mean, the relation was established at second. Okay, let's check now other possibilities, because I just want to fix this to, or to stick to CCNA information. For example, for the topology, you can display, and you will see various information about the topology of the EIGRP. I will cover this in future videos. because I just want to stick to CCNA label. And you can also show the traffic, show EIGRP traffic. All right, and here you can see the number of hellos, messages sent, received, the updates and received, queries, replies, acknowledgement, and they are consistent actually. So you see, so everything is fine. So this is how we display all this table. Now understanding exactly what's going on here, we'll see this hopefully in future videos. Thank you for watching.